All right, let's go ahead and get started. I want to welcome you to this worksheet. This is Net Ionic Equations Part 1. And writing net ionic equations is a very important skill because it really helps us to understand what's happening in the reaction vessel when we add an aqueous solution to an aqueous solution to form a precipitate. So these are the directions. Show the total ionic and net ionic forms of the following equations. If all species are spectator ions, and I'll explain that in just a moment, but if all species are spectator ions, then what we're going to do is indicate that no reaction takes place. So you need to make sure the original equation is balanced before proceeding. So let's take this nice and slow and make sure that we understand this. So we're going to start out with this equation right here, this chemical reaction. We've got silver nitrate, that's AgNO3, it's aqueous of course, being combined with KCl, aqueous. And what we get is silver chloride, that's a double replacement reaction, and KNO3. Now I want you to notice that we get a solid, and if you're not convinced of that, then look at your solubility chart and make sure that you know how to determine that silver chloride is indeed a precipitate. It is a solid. So we're going to get a reaction. But exactly what's happening in the reaction vessel? Well, when we place this silver nitrate into the water, it does say aqueous, it's going to immediately break down into Ag plus, notice we keep the aqueous symbol, and NO3 minus. So those two ions are going to kind of come apart in solution. So these two are present in solution, at least initially. Then KCl will also dissociate. K plus is one of the ions and Cl minus the other ion, right? So we've taken care of the left-hand side of the equation now. We know what the major players are. AgNO3 dissociates into Ag plus and NO3 minus, and KCl will dissociate into K plus and Cl minus. Now what's going to happen in the reaction? Well, what's going to happen is that Ag plus and Cl minus will combine to form a solute, a soluble or solid rather. So AgCl is a solid. Again, convince yourself if you're not absolutely certain. Use your solubility charts to convince yourself that AgCl is indeed a solid. But you're also going to get K plus and NO3 minus. Now I want you to notice that you had K plus and NO3 minus on the left side of this reaction as well. When you see elements that are both on the left and the right, then we call those spectator ions. We just cross them out because they really don't participate in the reaction itself. They're just spectator ions. So the only thing that's really happening is that Ag plus and Cl minus are combining to form AgCl. Once we eliminate the spectator ions, let me spell that for you. Once we eliminate the spectator ions, then we're left with what we call the net ionic equation. So this was the total ionic equation here. These are all of the ions that were present. And this is the net ionic equation. In other words, the total ionic equation minus the spectator ions. All right? So there's our first one. We've just done our first net ionic equation. Let's take a look at this one. The molecular equation is this. We've got MgNO3, that's magnesium nitrate. Notice we have to have a 2 here in order to balance the +2 charge of the magnesium, plus sodium carbonate, that's aqueous. Yields MgCO3, that's a solid. Convince yourself that that is a solid if you need to by looking at your solubility chart. And NaNO3, this one's aqueous. Now we're going to balance this correctly. Notice I have to have a 2 here in order to balance this correctly. That's important. So let's now write the total ionic equation. What's going to happen when you put these things in the solution? Well, the MgNO3 is aqueous. It's going to break down into Mg2 plus and NO3 minus. But there's 2 of them. So I'm going to put a 2 right here. There's 2 of the NO3 minuses, so I'm going to put a 2 in front of the NO3 minus. Notice I keep the aqueous signs on both sides. Now how about the sodium carbonate? Sodium carbonate is going to break down into 2 sodium ions. Notice there's a 2 right here. So 2 sodium ions, aqueous, and CO3, 2 minus, It has a 2 minus charge. CO3, 2 minus. You could have written that minus 2 if you'd liked. And also aqueous. So now we've taken care of the left side of this chemical reaction, this double replacement. What do we get on the right-hand side? Well, we get MgCO3. Notice in the ionic equation, the total ionic equation, the MgCO3 does not break down. Okay? It remains intact. That's what solids do. They're solid because they don't break down. But sodium nitrate will break down. So we have two of the sodiums. There's two of the sodiums right there. And here's the nitrate. I had to write this underneath because I ran out of room. But plus 2 NO3 minus 1, also aqueous. So now that we've got the total ionic equation, let's separate out the spectator ions. What are they? Well, I see 2 Na pluses on this side and 2 Na pluses on that side. I see 2 NO3s on this side and 2 NO3s on that side. And so what's left is Mg2 plus and CO3 2 minus, forming the MgCO3 solid. And that then would be my net ionic equation. Mg2 plus, aqueous, plus CO3 2 minus, also aqueous, forming MgCO3 solid. That's my net ionic equation. All right. In the next problem, we're going to be looking at converting from words into the molecular formula first, then the total ionic formula, and then the net ionic formula. So let's do that. First of all, we've got strontium bromide. Strontium bromide is SrBr2. That's because strontium is in the second column. When they do the switch, the 2 comes down here, so that's SrBr2. That's aqueous. Plus potassium sulfate. Notice we've got a polyatomic ion involved. It has a charge of minus 2. Potassium is plus 1, so when I do the switch, I get K2SO4. No parentheses around the SO4 necessary. That's also aqueous. And I form this solid, strontium sulfate. That's plus 2. The sulfate was minus 2. So they balance each other out. Right? They balance each other out. And I get a solid. Plus 2 KBr, that's aqueous. So this is the molecular formula that I've written simply by reading from these words. But that's not what's actually happening. What's actually happening is the SrBr2 is dissociating into solution into Sr2 plus, aqueous, and 2 Br minuses. Notice the 2 here. So there's a minus sign right there. Plus, let's take care of the K2SO4 now. What's it going to do? 2K plus, there they are, and SO4, 2 minus. There it is, and that's aqueous. Yields, now remember, the solids don't break down. That's why they're solid. They remain intact in solution. So we'll leave it alone. SrSO4 is a solid plus 2K plus aqueous. There's 2 of the K pluses. There's also 2 Br minuses. Let's find our spectator ions. Well, on the left-hand side, we have 2 Brs here, and we have 2 Br minuses here as well. We also have strontium 2 plus here, and we have, no, I'm sorry, strontium is not a spectator ion. Let me erase that. So it is not a spectator ion. It shows up in the, that should be a 2 right there. Just like that. So it shows up there. But the other spectator ion is going to be potassium. So we're going to have potassium here, 2 potassiums here, and 2 potassiums here that will not show up in the net ionic equation because they're on both sides, so they are spectator ions. So we have Sr plus 2 then, plus SO4 2 minus, those are both aqueous, yielding SrSO4, that's a solid, and that is our net ionic equation. That's number 3. Let's look at number 4 now. On number 4, we have manganese 2 chloride, aqueous. That's MnCl2 because the charge on the manganese was plus 2 and that 2 came here. Manganese plus 2 chloride, that's aqueous, is MnCl2, plus ammonium carbonate. This time we've got two polyatomic ions. Ammonium is plus 1, carbonate is minus 2, so when we do the switch we have to put a 2 right here, so that's ammonium carbonate. That's aqueous, yields manganese 2 carbonate, and it's a solid. That one won't break down. Plus ammonium chloride, that's NH4Cl. Notice to balance, I'm going to have to put a 2 right here because I have two NH4s over here on this side. I've also got two Cl's right there. So this is going to balance with a 2 right in that position there. Let's write the total ionic equation. Well, the total ionic equation is going to break the MnCl2 into Mn2 plus, aqueous, and 2 Cl minus, also aqueous. The ammonium carbonate is going to break down into two NH4 pluses, and that's aqueous, plus a CO3 2 minus, aqueous. That'll give me this solid, which does not break down. The manganese carbonate 2 carbonate remains intact, plus 2 NH4 aqueous, 2 NH4 aqueous, plus 2 Cl minus aqueous. Let's find our spectator ions. Well, I've got 2 Cl minuses here. I've got 2 Cl minuses here. What else? I've got 2 NH4s there. I've got 2 NH4s there. Those are spectator ions. Everything left is my net ionic equation. So we have Mn2 plus, aqueous, plus CO3 2 minus, aqueous, yields MnCO3, this time solid. And now the last problem. We've got chromium 3 nitrate, aqueous, plus iron 2 sulfate, also aqueous, yielding chromium 3 sulfate aqueous and iron 2 nitrate aqueous. The fact that there is no solid formed here should be a very big clue that we're not going to get a reaction, but let's go through the process anyway. We have chromium nitrate, chromium 3 nitrate, it's like this, that's aqueous, plus iron 2 sulfate, that's FeSO4, yields chromium 3 sulfate, that's the chromium 3 sulfate is here, plus iron 2 nitrate, we'll put that over here, and 2, 3, 3, 1 balances this equation. Let's break it down. When we break down the CrNO3, I get 2 Cr3 plus, that's aqueous, plus 6, that's 2 times 3, 6 NO3 minuses, that's aqueous, plus, we'll break this down now, we get 3 Fe2 plus aqueous, plus 3 SO4 2 minuses, 3 of these, also aqueous, yields 2 Cr3 plus aqueous, plus 6 NO3 minus aqueous, plus 3 Fe2 plus aqueous, 3 Fe2 plus aqueous, plus, finally, 3 SO4 2 minus. But look what's going to happen. We've got 2 of these, and we've got 2 of these. We've got 6 of these, and we've got 6 of these. We've got 3 of the Fe2 plus, 3 Fe2 plus on the right-hand side. We've got 3 SO4. We have 3 SO4 2 minus over here. Everything is a spectator. There's nothing left. There's no reaction. So we're going to put for the net ionic equation, no reaction, and that'll do it for this particular worksheet. I'll see you on the next one. Thank you. Bye-bye.